Good morning, guys. It's Navin joining call. Can you guys hear me? Could you please type in the chat window? Great. Thank you, guys. Just give me one moment. Sorry about the delay. And let's see. Sharing the screen now. And let's go and get started, guys. Okay. So we're in the journey of Python, and we'll try to understand a few more concepts and details of Python, guys. We'll continue the journey. And before we continue the journey, just a quick and a friendly review, guys. I will just ask a few questions. Please try to answer in the chat window, or you can try to come online and just answer them. And so let's see where we are, guys. Okay. Do any of you remember what is Python, guys? How do you define Python, or what is the mantra of Python? Cool. So come back here. Okay, it's short and sweet. Python is a very high-level programming language. See, that's my favorite one. And there it is, guys. Python is a very high-level programming language. And let's see, do any of you remember what is the mantra of anaconda, guys? What is anaconda? Pardon me. Yeah, it is a stadium. It is like a stadium. It is like a car. What would be the mantra of Python, guys? What would be another friendly mantra of Python? Cool. Python is like the engine in the car, or it is like the game in the stadium. And what is the mantra of Jupyter, guys? It's like the playground. The friendly mantra is it is playground. The technical mantra is it is web ID. And let's say, okay. The technical mantra of Anaconda is it is a Python distribution. Just like in Linux, you have different kinds of distribution. We can also refer to that as a Python distribution, guys. Okay. And let's see. Then we started discussing about slightly lower level details, which is, so what is a cup, guys? What is the mantra of a cup? A cup is a variable, a cup is an object, as simple as that. What is tea? Tea is numerical data. What is coffee? Textual data. The technical mantra of textual or coffee is string. The technical mantra of tea is numerical data. What is green tea? Green tea is without decimals, which is integer. That is the technical mantra, guys. Okay. And ginger tea, you should be able to answer it. I'm sure a bunch of you have already answered it. Is what is float? Float is decimals. Float is the technical mantra of the ginger tea. Okay. And let's see, we also discussed about what is a list object, guys. A list object is more precisely a tray of different cups, tray in which you can have teacups or coffee cups, is what it is. Okay. And I'm going to step back a little bit. There is something special, a special characteristic about strings. Do any of you remember what is that special characteristic about string is, guys? That's a slightly tough question. It's immutable. Cool, good. Maybe Rahul is coming from a programming background. Generally, these are the things they reiterate multiple times and things like that, guys. Okay. So back to lists here. And let's say, come back here. So, sorry about that, guys. Okay, let's see. May go a little bit deep into these things. Okay, then we talked about Boolean operators. So, okay, sorry about that again, guys. Just trying to control my little one here. And we talked about the Boolean operators. We're here to talk about the dictionaries. And let's see what else we have. Okay. Okay, maybe here is a slightly tough question, guys. Do any of you remember what is the mantra of 03? When we say 03, what is the mantra? 0:3, my bad, sorry about that. 0 is inclusive. In other words, left-hand side is inclusive and right-hand side is exclusive. That is something I want you to manually keep in mind. Slightly important, guys. I will stress a little bit on that. Bear with me. What does -1 tell you? What does minus tell you? It is minus means come from the reverse order. And another slightly deep one is when you're coming in the reverse order, it is following a 1 based index, not a 0 based index. By default, it follows a 0 based index. Okay, what does :2 do, guys? Slightly tougher. It's giving you every second one, more precisely. Every 2 skip, okay, good one there. Is what it is. And let's see. So we looked at append. What is the difference between append and extend, guys? Add to the end, okay. Actually, append is add to the end, but what is extend? Good. It adds individual elements in the tray at the end. Append is adding the complete object at the end, guys, okay? And let's see, okay. Now, gentlemen, ladies, here is a slightly deep one, guys, okay? What are we doing in this line of code? Slightly tough question. Okay, in other words, more precisely, we are converting a range object into a list object that is called type conversion or typecasting. We'll talk more about it, but slightly deep on there, guys, okay? Then, gentlemen, ladies, what is the mantra of import? Slightly tougher. You're importing, short and sweet, you're importing would be the technical mantra. The friendly mantra is you're opening up the toolbox. Okay, you have to imagine a carpenter with a screwdriver and a hammer. He has to open the toolbox in order to access the hammer and the screwdriver. So that import is the opening, guys. Okay, and what is the mantra of NumPy, guys? Tough one. What is NumPy? Or the mantra of NumPy? NumPy is a package for arrays and matrices. It is a package. More precisely, it gives us arrays and matrices. Python by default does not have arrays and matrices, so that's why we use NumPy. As simple as that, guys, okay? And now there is a subtle difference between these two. Do any of you recall what is the subtle difference, guys? Or what is the mantra which is coming to your mind when you look at this one? That's a tough one. Vectorized operations, vectorized addition, element by element wise operation, and matrix like operations are some things to be kept in mind. So in other words, lists do not support vectorized operations, whereas arrays and matrices support the vectorized or the element by element wise operations. They become very, very important in scientific computing and mathematical computing world, guys. Okay, they are nothing but the linear algebraic concepts and things like that behind the scenes, which Python is shielding us. Python is abstracting or covering. We don't need to really worry about the internals, and all it does is it is automatically performing these operations for us, guys. All right. So in other words, more precisely, every one line of code that we are looking at here may end up being multiple lines of code in other programming languages, guys. Okay. And by any chance, do you remember what is matplotlib, or what is the mantra of matplotlib? Matplotlib is a package for visualizations, as simple as that. It is a package where we have paint inside our box. Now we are becoming a painter. When we are talking about NumPy, we are a carpenter. And we are talking about Matplotlib, we are like a painter, and we have paints and we have to paint it and we have to open that up. Okay. Do any of you remember what does linspace do, guys? That's a slightly deep one, a slightly tough one. What is linspace doing? I'll see if I can give you a hint here. Sorry, my resources are a little bit low on memory. And say, come here. Okay, equal spacing. It is generating the data. It is generating the numbers which are equally spaced. That is what is linear spacing about, guys. Okay, and let's see if I can find space. There you go. Okay, and we just gave a touch of the visualization package. Then let's see. Okay, now let's see if you can catch, guys. What is the mantra of an array? Mantra, it is a tray of similar cups. You can have either teacups or coffee cups, but you cannot have both the cups. That is what is special about it, guys. Okay. And okay, let's see, gentlemen, ladies, one more time, a slightly boring question. What is happening here? What is the mantra which is happening here? It's a simple answer. You just answered it, but I'm just for the sake of discipline. 3 and 5 times. Okay, 3 and 5 times up. Okay. I think you're almost answering it, Shri Shail. More precisely, element by element wise, good answer. Okay. More precisely, ones are getting each one. So there are going to be a tray of 5 ones. Each one is getting added to a 2. So that is like an element by element wise operation or vectorized operation, guys. Okay. And let's say scroll down. Okay, gentlemen, ladies, what kind of an object, let's say, is this one? It's a 2-dimensional array. As simple as that, it can also be called as a matrix. Okay, guys. And let's see, do any of you remember what does head stack do? How do you say what is head stack doing? And give me one moment. I just need a glass of water here. Sorry about that. Okay, sorry about that, guys. Okay, so short and sweet, head stack stand for horizontal stack. It is taking each item, which is each tray. So this is like a tray of two trays. It takes the first tray and from here and the first tray from here. It is putting them horizontally. That is what is referred as horizontal stack. A little bit of analytical thinking will be helpful for you guys. So do not underestimate. Do not be wondering why we are going into these things that much. Be absolutely sure these things will be helpful for you. In coming up days, you will realize, guys, okay? And okay, gentlemen, ladies, now the V stack doesn't seem to be working here. Can you give a thought why? Can you tell me why? It should be a simple answer. Okay, so notice for the reason, the dimensions more precisely, there are 4 cups in this tray and there are only 3 cups in the tray. For some reason, for more precisely a computer science reason, it is expecting equal number of cups in the trays is what is going on, guys, okay? Let's see. Sorry, gentlemen, ladies, what is the mantra of a function? What is the mantra of a function, guys? The mantra of a function can be thought of as a house, as simple as that. Reusability good. The technical mantra is code reusability. The friendly mantras will call that as a house, guys, okay? Now, let's say, okay, what is the meaning of indentation, guys? It is probably a very stupid question, but bear with me for the sake of discipline. And in a good answer, Shrishe, that's a good one. You can say it as a scope. More precisely, it's a friendly mantra is it is a tab, or it is defining the scope of the line of code which it is under, guys. As simple as that, okay? And let's say when we say I equals to I plus 1, what do we call that, guys? What are we doing there? Okay, it's incrementing, guys. Okay, a little bit of computer terminology and things like that. Again, one more time, if you keep hearing these things, they will be helpful for you and things like that. Most of the times what happens is when you're working with the US clients and things like that, imagine you really end up writing some infrastructure as code and things like that. They will be throwing these terms at you. Sometimes you may need to do a code review and explain to them and things like that. So terms like this are commonly used. So that is why I'm kind of throwing these at you and trying to get you familiar with all those things, okay? And let's see, gentlemen, ladies, increasing the complexity. Tell me, what is this one, guys? What is this called? This line, guys, what is this called? Okay, it's multi-line string. More precisely, it is called as a doc string. It is like a one-line help. One line, generally 1 or 2 lines at the most, a brief description of the function that they are running as, okay? Now take a look at this, guys. Here is greet and now here's what I'm going to do. I'm doing this one. I did something. In other words, I used some keys and I got this one. Do any of you happen to remember what is this one, guys? What did I do here? How did I get this one? What did I press to get this one? Very good. It's a shift and a tab is what it is more precisely, guys, okay? And let's say, okay, now, gentlemen, ladies, what is the difference between the line Hamara Bharat and Mera Bharat? In other words, more precisely, this is in the park. If you're outside the function, you're in the park. If you're inside the function, you're in the house. If you're in the park, then you're in the global scope. If you're inside the function, you're inside the house, then that is called the local scope. So Hamara Bharat line is in global scope. Mera Bharat line is in local scope is what it is, guys. Okay, as simple as that. And then we looked at a little bit of plotting and subplotting, just a touch of it. Okay, now let's scroll down. Okay, gentlemen, ladies, what is the difference between Brook Bond and Red Label? What is the difference between Brook Bond and Red Label? Very good. One more time, more precisely. This is a cup in the park. Red Label is a cup in the park. Brook Bond, Taj, and Lipton are the cup in the house. In other words, the technical mantra is it is in the local scope. Okay. So what's happening, guys? Why are we getting there? When we say Brook Bond, we're getting there. Why? Very good. So in other words, more precisely, we're trying to access a cup in the house in the park. Brook Bond is a cup in Ravi's house, and we're trying to access it outside the house, which is in the park. We cannot access the local variables in a global scope. Again, this is a slightly technical terminology that you need to be familiar. You need to kind of become a friend of it, guys. Okay, bear with me. Don't hate me because I'm throwing these terms at you. They will be helpful for you. Okay, so that is what is the story of the global scope and the local scope. And the gentlemen, ladies, maybe a stupid question. Tell me what is the problem here in this function? It's a simple question. In other words, more precisely, Bharat is in global scope. Inside a function, the statements or the lines have to be in the local scope, not in the global scope. Sorry about that. Okay. And let's see. Okay, gentlemen, ladies, what is the function input doing? Oops. Slightly important, guys. A simple one. Very simple answer, Rahul. That's a very good way. It is taking the input, or it is asking the user to enter the input. When we say 10 here, we are hard coding it. When we say Nescafe equals to something, we are hard coding. That's where we're explicitly hard coding. Whereas when you say input, you're not hard coding. You're expecting user to enter something, is what is going on, guys. Okay. And gentlemen, ladies, there is a small catch here. Let's say, let's see, here is X. What is X? X is the input. And now what is special about the variable X here? It is a string. Very good. It's a simple one, guys, but I want you to keep in mind anything, even though we say we are entering enter a number, even though we enter a number, the input is converting everything into a string. No matter what you enter, it will convert it into a string is something I want you to keep in mind manually, guys. Okay. And let's see, gentlemen, ladies, let's see, tell me what is happening in this line. There is something happening in this line. What's the catch? We are converting it to an integer, typecasting, type conversion. Again, a big term and a small thing you need to be familiar with. Okay. And let's see. Okay, gentlemen, ladies, what is Nescafe here? What is special about Nescafe here? Nescafe equals to espresso. What's happening here? Okay, so in other words, more precisely, Nescafe here is a global. It's a cup in the park, whereas Nescafe inside, which is a local variable or a cup in the house. Okay, now Nescafe already has coffee. Now when we say Nescafe equals to espresso, I want you to manually remember. Python is observing that there is already a cup in the park or a global variable called Nescafe. And what Anuj is trying to do is his intention is to modify. he wants to put espresso in this cup. There is already coffee in this cup. So what Python is going to do, I want you to manually remember Python is creating a new cup in the house. This is going to be a new object within the house, and it is different from the cup in the park is something I want you to manually remember, guys. Okay. Now, gentlemen, ladies, let's say, take a look at this. Here is Shilpa. Shilpa is saying Nescafe. What do we say in a computer science terminology? What do we say this statement or the line is doing? What is happening in the function of the house of Shilpa? What do we say there in computer science terminology? Pardon me, sorry about that. I know you're not coming from computer science background. Cool. We say we are accessing a global variable, or we are bringing the cup in the park inside the house. The friendly mantra is you're bringing the cup in the park inside the house. The technical mantra is we are accessing a global variable. Shilpa is not modifying it. Only if you modify it, notice Anuj is modifying it, Python will create a new cup. Whereas if you're just accessing it, Python will not give you a new, there is no need for Python to create a new cup, but it is just going to give you the cup in the park inside the house. Is what I want you. So in other words, you're accessing a global variable is something I want you to keep in mind. Cool. So there is Vivek, here is Urvashi. Urvashi is doing something wrong, guys. What is Urvashi is doing? How do you say it? Cool. Okay, if you're still thinking, we can access a global variable, but we cannot access a local variable. In other words, you can bring a cup in the park inside somebody else's house, but you cannot bring a cup in somebody else's house into your house. Urvashi is trying to bring Taj. Taj is a cup in Vivek's house. She's trying to access the Taj. You cannot. Whereas you can access a global variable. You cannot access a local variable. Okay, guys? So that is a little bit about the accessing of the global variables and the local variables. Gentlemen, ladies, what is special about Rutu? Function of Rutu, house of Rutu, what is special? Cool. So we are modifying a global variable. You can access the global variable, you can modify that specific variable. If you do not say global Nescafe, then Python is going to create a new object, new cup called Nescafe. But if you say global Nescafe, you are telling Python explicitly, you're taking permission and saying, hey, I want to modify the cup in the park. I don't want you to give me a new cup in the house, is what you're saying. That is something, something important, something you will constantly see people will be doing this. Okay. Then again, take a look at this. Here is brew, and we're getting an error. Tell me, what is this name error talking about, or why we're getting this error, guys? Why are we getting error? It's a simple one, or maybe it's a medium complex one. Rahul, give a thought, buddy. Okay, so we are getting we have not yet created a global variable or a cup in the park, and we are trying to access it, so it's complaining. Now Prabhakar is saying global brew. So what is special about this global brew, guys? Sorry about that. Just give me 1 minute, guys. Sorry about that. Sorry about that, guys. So in other words, what is happening here, guys? Global brew, if you do not have a global variable called brew, we can also create a global variable inside the function or inside the house. If the cup in the park does not exist, what is happening is Python is allowing you to create a new cup in the park inside your house. Again, a little bit of computer science related stuff, guys. In other words, the technical mantra is we can create a global variable in a local scope. When we call this function, we are entering the house, we are in the local scope. Inside the function, we are creating a cup, which is a cup in the park, which is going to be put in the park, is what is special about it, guys. Okay. And now that the global brew is allowing us to modify that cup in the park. Then we are modifying the cup in the park. Cool. I think that is where we were yesterday. Most of them were the permutations and combinations of these things. So let's continue the journey, guys. Okay. If you have followed these things, then for most likely you should be able to comfortably practice them, guys. Say, okay. So let's see what we have. Chandra. So we already have a cup in the park. Here is Chandra Global Nescafe. So we are taking the permission. Put ginger tea, no problem. Put Nescafe, print Nescafe, no problem. Then again change it to latte. Then print it, global brew, get the permission for brew. I don't see any problem in this one. Just a quick review from yesterday. So here is Chandra. So there it is. So originally it looks like somewhere yesterday we changed Nescafe to latte. Okay, remember when we executed this, it did not print this one. We need to call the function, guys. You just don't create a function and leave it. After you create a house or after you build a house, you need to go inside the house. And how do you go inside the house? That's where we're calling the function. That's something I want you to keep in mind, guys. Okay. And okay, now return. Gentlemen, ladies, what is the mantra of return? Anybody recall? What is return doing, guys? Simple answer. Sorry about that. Return is returning. So if you just say print, if you just say Levista equals to filter coffee and things like that, then what's happening is you're just executing the code. Whereas when you say return, when you're coming out of the house, a gift is being returned. That could be a teacup, a coffee cup, or a complex object that we'll be seeing. Is as simple as that, guys. Okay, everybody with me so far? You can return any kind of objects when you're coming out of the function. Sometimes, based on our requirements, we will return. Sometimes we may not return. That is what it is about. Quick yes, please. Okay, so now let's see. A simple one will increase the complexity here. We'll move on to other ones. So, gentlemen, ladies, what is Nescafe here? Okay, I'll simplify it. Nescafe is nothing but the first cup in the tray. Okay, so in other words, more precisely, let's see what I'm trying to do is take a look at this one. Imagine a waiter one is carrying a tray. He has a coffee, cappuccino, and a green tea. Here is waiter one who's carrying a tray. That's a tray of 3 coffee cups. Now, when you say waiter one of 0, you're telling him, hey, buddy, can you give me the first cup in the tray? Visualize for a moment, you're telling him, hey, buddy, can you give me the first cup in the tray? And it's giving you coffee. But let's say here is waiter 2. Okay, now take a look at this, guys, increasing the complexity. Now, this is a waiter who he's also carrying a tray. And what is special about them? You tell him, if you want coffee, you don't tell him. He will not understand. If you tell him, say, waiter 2, give me 0, notice, he'll give you an error. He wouldn't understand that. What should you do? You should say, waiter 2 of Nescafe, and then we will get coffee. In other words, more precisely, let's say, come here, this here, this here, this here, this one here. Okay, so visualize for a moment. 3 coffee cups, and here is, that is waiter 1. Here is another tray, but there is something special about this tray, guys. Okay, let's say we'll put coffee here, we'll put cappuccino here, we'll put brew instant coffee here. Now, what is special about it is this Nescafe is a label. Think of it like a saucer. Think of another saucer. This is Starbucks. Think of another saucer. This is brew. Okay, the friendly mantra is it's like a saucer or a label. The technical mantra is a label. The technical mantra is a key. So this is a waiter If you tell him, give me the first cup, this waiter will understand, but this guy will not understand. What you tell him is, you tell him, hey buddy, give me Nescafe. When you say Nescafe, that guy is looking here and then giving this cup here. So what is this? This is also a tray of cups and saucers or cups and labels. The technical mantra is it is called a dictionary. A dictionary is something which is a group of keys and values. The cup is going to be the value. The saucer is going to be the key. Together we call this as a key and a value. What do you do? If you want the value, we access this by a key. In other words, let's say, come back here, scroll down. So here is waiter 2. Let's say here is Starbucks. Let's run it. Take a look at this. You get cappuccino. So Starbucks is the label or the saucer. And then you say cappuccino. You cannot say 2. You cannot use indexes. You have to use the keys. So you can also think of this as a pen and a cap. Or maybe this is a pen, this is the cap. Cap and a pen. Cap 1, pen 1, cap 2, pen 2. And things like that is what it is. So let's dig a little bit deep into them. This is a slightly complex and important data structure. So there is Starbucks. Now take a look at this, guys. Come here. Here is, one more time, waiter 2. You run it, you get a tray. Now what you do is, say, waiter 2 Starbucks equal to mocha, and look at what happens. So waiter 2. When you say waiter 2 Starbucks equal to mocha, notice it is changing from cappuccino to mocha. It's getting changed from cappuccino to mocha. In other words, what is happening? You can modify this tray. Just like a list object, which is a tray of different cups, which can be modified. The dictionary is also a tray, which can be modified. We just changed cappuccino to mocha is what it is. How do you modify it, guys? Again, you're not going by index. You're going by the label. The label is called the key. You access it using the key, and then you can put whatever value you'd like. Everybody with me so far, guys? Quick yes, please. Okay, so say come here. Now take a look at this, guys. We just modified it. Now we are going to say brew equals to, we have brew equals to instant coffee. Let's say come down here. And now notice this is modifying it to frappe. From instant coffee, we modified it again. In other words, now take a look at this, guys. Here is caribou. Caribou equals to latte. Take a look at this. So what is happening is, it is, the dictionary is saying if this key and value are there, if the key is there. Caribou is not there. We just have Nescafe, Starbucks, and brew. So it is adding the key and the value. It is adding the cup and the saucer, or the cup and the label, or the cap and the pen. Catching it, guys? Quick yes, please. The thing is whether you modified the syntax or whether you added the syntax is the same. Everything we are doing by the key. That's something we need to manually remember. Quick yes, please. Shri Shel Kajal. Cool. Notice again, if you notice, we do not have cafe day latte. Now here's another slight deep thing, guys. Okay, yeah, slightly important thing. Let's say come here. Take a look at this. Say, put this here, put this here. So imagine this is a tray. So here's a coffee, here's a mocha, and here is frappe, and then comes latte. Now notice, here is latte, here is latte. Okay, now let's say, for the sake of simplicity, we'll say here is Nescafe, here is, what is this one? We'll choose this one, Starbucks. Here is, and come here, brew, and I'll choose this one, caribou, and then lastly we'll choose this one. Here is cafe day. Now notice, guys, what is special about the dictionary is the values can be duplicate. Notice latte and latte, but you cannot have the keys, the duplicate. Notice the colors. Every color is a unique color. You cannot have duplicate keys. If we say right now our cafe day has latte, right? So now one more time for sake of discipline, we'll say, okay, this one, here's this one. Sorry about that. And let's say instead of latte, Let's change this back to tea. Okay, now take a look at this, guys. What happens is, notice the latte has changed to tea. When we are accessing by the key, it is not adding cafe de tea again. It is modifying the latte with the tea. In other words, something I will ask you to manually remember is a dictionary is a group of keys and values is the first technical mantra. The second thing is it has unique keys. The keys are going to be unique. The values can be duplicated. The values, you can have same multiple values, but the keys will also be, the keys will always be unique is something to be kept in mind. Catching the point, guys. Quick yes, please. Okay, so let's take a look at a few more. So there it is, cafe day. You're now modifying cafe day. So what it is doing, if the key is already there, we already modified it to a tea. Now we're going to be modifying it to sunrise coffee. From tea, we have modified it to sunrise coffee. Notice that at any point of time, the keys are unique. You cannot have a duplicate key. A dictionary will not allow a duplicate key. Nescafe can be there only once there. Now cafe day 2 we don't have. So let's say cafe day 2 and latte. Notice cafe day 2 is getting added. Okay, so if the key is not there, it is adding the key. If the key is there, it is replacing the value. One moment, guys. Sorry about that. Sorry about that, guys. Okay, so just for the sake of discipline, now take a look at this, guys. Here is waiter 2t. We don't have a key and a value t. So notice t is getting added. And now here is another observation, guys. Notice all of them are coffee cups. And here is a teacup, which is numerical data, which means most of the times the keys are strings, textual data, but the teacups, coffee cups are complex objects also, is what it is, guys. Okay, let's say come back here. Okay, so now take a look at this. Waiter 2 tray. Waiter 2 tray. So there it is. Tray is acting like a key, and this is a complex object. A list is a complex object sitting as a value inside the dictionary. So your values can be complex objects, but the keys are always strings or textual data, or maybe what we call in a friendly way, the coffee cups only. Okay, guys. And let's say now, again, a few more things. Notice this, waiter 2, say waiter 2. Let's do it, dot keys. So these are all the keys. If you say keys, it's giving you all the keys. Now, how do you know that I have something called keys, guys? You can say waiter 2 dot or shift and a tab. Now notice if you give a shift and a tab, okay, here it is going to give us a help. There are other ways to get help. I'll explain you in a bit. But let's say you can also say waiter 2 dot do and do a tab. So here is the keys and then the values. So on a need to basis, we need to, in a real world, you may just need to look at some of these functions, and try to understand what they do. And if somebody else has used something called values, say values here, notice it gives us all the values. The values are on the right hand side. The keys are on the left hand side. So keys gives all the keys, values gives all the values is what it is. These are a couple of functions or methods which are available inside this object. And more importantly, any object you can say waiter 2 dot and I'm doing a tab and it will bring up. This is an IntelliSense help. It will bring up a group of functions or methods available in that object. Everybody catching it, guys? Quick yes, please. That's another short and sweet and a quick way to get some help. A much more detailed help, I'm coming. I'm slowly heading there. I'll tell you how to get a much more detailed help. Quick yes, please. One more time. Rahul, Shrishel, okay, buddy? Okay, looks like we are starting another one here. Okay. Okay, so gentlemen, ladies, Is it okay if we just take a short 5-minute break and regroup, please? Everybody okay with that? Rahul, Srisha, okay, please take a 5-minute break. It's 10:54, 10:55, and we'll get back, guys. Thank you. Sorry about that. Okay, back guys. Okay, so let's continue the journey, guys. And one moment, please. Can you hear me, guys? Quick yes, please. Sumit, can you hear me, buddy? Okay, thank you. Oh, sorry about that, guys. I think I went on a mute. Okay. Okay, so back to a little bit of input. Favorite is your global variable, just a quick review. And Nescafe is the content. So favorite is a cup, Nescafe is the content inside it. Remember, input is asking a user to enter some data instead of hard coding. So this is hard coding the data. Here, we are asking the user to enter. We just discussed about that, guys, okay? So let's move on to a few more permutations and combinations. Okay, let's see what else we have here, guys. So back to a list object. We're taking some random numbers. And let's see. Just like you have some of the Linux commands and things like that. These are some of the functions which are available, guys. Length is telling you how many cups are in the tray. It is giving you the size. And let's say numbers.sort. You can also sort the numbers, just like a sort command in Linux. And there it is. It's sorting in ascending order. And if you'd like to look at more options, just put your cursor there, do a shift tab on my chat window here. So expand this. Oops, one more time. Shift and a tab and scroll down. You can read a little bit. These are some of the reverse. I'm here to explain what these arguments are and things like that, guys. Okay, we're slowly going there. So sort is sorting as simple as that, guys. Okay, then you can also do the reverse. So reverse equal to true. By default, it is ascending order. If you say reverse equal to true, it is going in a descending order. Okay. Let's see what else we have. Okay, now take a look at this, guys. A little bit of loops and things like that. There's a tray, 3 teacups. Sorry, I think I don't need this one. There's a tray which has 3 coffee cups. We'll start with 3 coffee cups, Nescafe, Brew, and Sunrise. Now, imagine a scenario where we need each cup at one time and we need to do some special kind of processing and things like that. What do we do? That's where we can use a for loop. Okay, notice it gives you an error. The for loop is something where if you just say for coffee in tray, it is going to pick up each cup, but you need to tell it to do something. Here, we have not told what to do. So what do we do? Ideally, if you don't want to do anything, you should say pass. Pass is something, again, a keyword. Notice it's in green color and bold color and bolded. And what is pass? Pass is do nothing. Sometimes here and there and many times it is many times you will come across scenarios where you just want to write a line of code and maybe you're waiting for requirements. Maybe you want to just keep it there for a temporary time and things like that. What do? You just say pass. You're telling Python, hey, don't do anything or do nothing. The mantra of pass is do nothing. Okay, but let's say, take a look at this. Say print coffee. Notice it is, why are we getting this one? Oh, what's that? Oh, sorry, my bad. This is coffee. Okay, the coffee is another object with a double F. That's why I was getting that one, guys. Okay, they are used a single F here. So there is Nescafe, Brew, and Sunrise. So in other words, what is happening is, just for sake of discipline, allow me to just put it like this. a tray, 3 coffee cups, brew, and a sunrise. So the way the thing is working is something you need to remember from a programming terminology is the coffee becomes the pink. It's picking up each one. So coffee is like a local variable and the scope of the for loop is something which you need to keep in mind. Okay, so that becomes coffee. You can do whatever you want. Here we're printing. You may want to save it to a file. You may want to do other things and so on. That is what we'll see in the coming up days, guys. Okay, many times. And then just visualize as if it is putting it back there. Then what does it do? It goes and picks up the next one. And this is also referred as a sequence. And now coffee becomes the blue. And after that, sunrise becomes a coffee. Everybody able to understand that, guys? Quick, yes, please. So every time we're talking about a for loop, just visualize the cups or the items are going to be picked up like that and they're going to be processed and so on, guys. Okay. Okay. For the sake of discipline, you can also use another function called reversed of tray. So let's say, scroll down, here is reversed of tray. There it is, sunrise brew and Nescafe. So reversed of tray is printing the reverse. As simple as that, guys, okay? It's you just visualize these are reversed, or in other words, it is going from right-hand side to left-hand side, not from left-hand side to right-hand side is what is reverse doing this. And let's see. Okay. For cup, now here is a tray of teacups, 3 teacups. We're using a for loop. It should print the 3 teacups as simple as that, same as above. And again, for the for loop, 2 conditions. One is it will always force you, Python is going to force you to say, hey, give me a colon. That's a small syntactical thing, but a slightly important thing. Always need to remember, if you don't give the indentation, it will complain, hey, you better give me the indentation or I'm not going to work. In other words, it is forcing you, it is more of a syntactical requirement that we need to keep in mind for also, guys, okay? Now, gentlemen, ladies, increasing the complexity, take a look at this. What we are doing is, here is 1 line, 2 lines, 3 lines, 4 lines, 5 lines. Notice this 5 lines. I'm going from this one. Notice it is printing 1, 2, 3. Okay, so for a moment, let us say, come here, put this here, put this here. So visualize for a moment. The first step is we created a tray. We have 3 cups in this tray. And now in the second one, we're creating a new tray. We're calling that as temp list. This is the second step. That's an empty tray. Then what we're doing is we are picking the for loop. You pick up each cup, there is a 1 inside it, you do auto processing. So that is printing. That is actually what that is doing is you visualize as if it is copying and pasting it here. Here, it is picking up the cup. In the next line, it is taking the cup and it's saying append to the empty tray. So it is adding it. So even though I'm doing a cut and a paste, you just visualize as if it is doing a copy and a paste is what it is. Then the next line is where it is just printing the newly added cups into the newly added tray. So more precisely what we have is 1, 2, 3, 4, 5 lines of code. Now take a look at this. Cool. If I run this, notice it is exactly giving us the same output. What is special about it? It is just 1 line of code is what is happening here. In other words, let's say, come back here, snap this. What was 5 lines of code earlier is now reduced to 1 line of code. What is this? This is called list comprehension. Choose this one, choose this one. This is called list comprehension. Most of the times, the modern Python developers, modern Python programmers, instead of writing the for loops like that, writing a bunch of lines of code, they are most of the time using patternized code like that. Once you get used to it, you will start liking it. You will start using these things, and you need to be very familiar with this. This is more of modern way of Python programming. In other words, what is happening is the for loop here, which is here, it is taken and put here. Okay. And now what happens is the list is a tray. So let's say come here, choose this one. The list is a tray in which there are 3 cups. Now what is happening is the first one is picked up by the for loop, that becomes a cup. Now, after this stage, what happens is from here, it is just going to the left-hand side. Here we are traveling from right-hand side to going from right-hand side to left-hand side. And what's happening? It is being added to the new tray. That's a new tray. Okay, so in other words, let's say, come back here. Think of this as a new tray. So what it is doing is, you pick up this cup, move to the left-hand side. What are you doing? You take that cup as it is and add it to your new tray. It becomes a 2. The same process repeats. Pick up the cup and add it to this one, and there is a new tray. So this is roughly actually 1 or 2 lines of code with the declarations and things like that. So we can say 5 lines of code has been reduced to maybe one line of code. This way of writing the code, a modern way of writing Python programming code, is referred as a list comprehension. A slightly important and a slightly or a very important one also, guys. Okay, so now just to digest that one, let's say come back here, take a look at this one. Cup, say +1. Okay, now we'll copy this one. This one. Now take a look at this. It has become 2, 3, and 4. So in other words, more precisely, if we come back here, put this 3 back here, what it is doing is, you visualize it creates an empty tray. The final output is an empty tray. But what it is doing is, it is picking up the cup. That becomes a cup. Instead of cup, we have cup +1. So here we are changing the value, and now that becomes a 2. You repeat the same process. Pick up the cup. Whatever processing you want to do, you write it on the left-hand side. That becomes, and then put it here. That becomes a 3. And then repeat the same process. There's a cup, add it to the left-hand side, but we're doing a cup +1, so that should become a 4. Everybody catching it, guys? Quick yes, please. So here, this is called list comprehension. I will kind of ask you to remember it manually. And let's say come here. Now notice this one. You pick up a cup here, and this one is going from right-hand side to left-hand side. In other words, the processing generally in for loops is going from left-hand side to right-hand side, whereas here we're going from right-hand side to left-hand side. List comprehension, the mantra of list comprehension is, it is generally 1 line of code. Later we will see 10 lines of code can be written in just 1 line of code. Sometimes even more lines of code can be just compacted and written in just 1 line of code. That is really, when you gain a little bit of experience, you will really start appreciating it a lot, guys. There are a bunch of techniques in Python which will help us. That is one of the reasons why Python is becoming a favorite to everybody, and everybody wants to do everything in Python, guys. Okay, so the first mantra is, it is 1 line of code. Second mantra is, we are going from right-hand side to left-hand side, not from left-hand side to right-hand side. By default, we are always going from left-hand side to right-hand side, is another friendly way to keep in mind. Everybody with me, guys? Quick yes, please. Shishel, Rahul. Cool. Shishel, Rahul, yes, guys. Are you guys doing okay there? Have you given me yes? Can you type in yes one more time? Okay, thank you. Okay, so tray empty, an empty tray. If length of empty tray is greater than 0, a simple example of an if block or an if loop. They generally call it as a block rather than a loop because loop is continuous, whereas this is only a one-time check. Length is just checking the size. If it is greater than 0, well, there is 0. There are no cups, so it says, hey, the list is not empty. And what is happening is, so here, since this condition is not true, what is happening is the print is not getting printed. Okay, so in other words, let's say, come here, put this here. Now say else colon tab, say print, say put in quotes, say the tray is empty. So the same thing, we're also adding an else condition. If the condition is not passed, then the else block will get triggered. If the execution will go into the else block, the tray is empty. So if this condition is satisfied, the print, this is going to be executed. Otherwise, this is going to be executed as simple as that. Everybody with me, quick yes, please. Can you handle that? Okay. Okay. So tray is Nescafe. One more time, just the same thing, another way to do it. 3 coffee cups in the tray. We're checking if the length is greater. And again, for the if block, more precisely, notice the colon, notice the indentation. is mandatory, guys. Okay. So there's a tray, 3 coffee cups. Is it greater than 0? Yes, it is greater than 0. Now the print will get printed. Method 1, the list is not empty, because this condition is executing to be true. If this is true, then what's happening is it is going to the scope of the if block, is what we say. And let's see what is different here. Again, I'm saying, hey, you need a colon here and you need a indentation here, is what I'm kind of holding your hand there and feeding you. And print method 1. So this is one method. Take a look at this. If tray is not equal to empty tray, print method 2. So in other words, we know that in our tray, there are 3 coffee cups. What is this doing is actually this syntax is slightly confusing. Tray is not equal to empty tray. And what is this tray? This tray has 3 coffee cups. Yes, it is not equal to. So what is happening? That is getting printed. In other words, more precisely, this condition is evaluating to be true. Getting evaluated to be true. Catching the point, guys? Just another way of executing the code. You are manually checking. You will probably rarely do that. Most of the times we are writing this kind of code. You just check the length of it for performance reason and things like that. And print tray. And now take a look at this, guys. Print tray will print the tray here. If tray, this is slightly confusing, but it is always a good idea to be familiar. What we are doing is the tray has 3 coffee cups. Nescafe, brew, and sunrise. What we are doing is if you just say tray, what the if block is doing, more precisely what Python is doing is the Python is checking if the length, if the size of the tray is 0 or not. What is this one? We did not give any condition. But what is Python doing? If you come across a syntax like this, it is good to be familiar and good to be aware of that Python is checking the size of the tray. Catching the point, guys? Quick yes, please. That's slightly unusual. In a Java and a .NET world, you will not find this kind of code working for an if block, but in Python, it is supporting it. So just be aware of that, guys. Okay, you don't need to be by hearting it and things like that. If tray empty, same thing. Whatever is here, I just change the name. So I'm giving an empty tray. Now take a look at this. What we'll say, we'll plug in an else here. Else, say print. Just say empty. It's an empty tray. So if condition is not getting satisfied, then it is going to the else block. Okay, guys, hopefully you guys are able to handle that one. Just be aware of that one. Now, gentlemen, ladies, increasing the complexity. Let's see, we have not really talked about what is called a tuple. So let's say, I'll give you, let's say, copy this one. Here is students. And one more time, here is students. What we'll do, this is John and 95. Okay, imagine I put something like this. Let's start with this one. Okay, so what is this, guys? This is a list object. John 95, maybe that is his marks, Aaron 92, and David 100 is what we have. A tray with a coffee cup and a teacup. And another coffee cup and a teacup is what we have. Okay, what is this? This is a list object we have looked at. Now take a look at this one. Before I go deep into it, a quick introduction. Here is a normal bracket instead of a square bracket. This is called a tuple. Here is students, say students of 0 equals to, let's say, Rahul. Okay, and then we'll say, what is students? So we'll start with this list object. Okay, so John 95 and things like that. Now change students of 0, that will change John to Rahul. If you look at students, the John has changed to Rahul. Simple one. In other words, more precisely, a list object is something which is allow you to change the cups inside the tray. But come to what is called a tuple. Here is a tuple, which is just an open bracket rather than a square bracket. We use a open bracket. It is same as a list object, but you cannot modify it. In other words, now you say students of 0 equal to Rahul. Notice what happens. It will give you an error. It says tuple object does not support an assignment, means you cannot modify this tray. A tuple is a tray which is immutable, just like a string. You cannot modify a tuple tray. You can modify a list tray. A tray which cannot be modified is called a tuple. If you take the days of a week, Sunday, Monday, Tuesday, Wednesday, and so on up to Saturday, or maybe the months January to December, in a practical scenario, generally we don't change the days of a week, we don't change the days of or the months of a year. What do? You can create a list object, but you can also create a tuple object. A slightly more better way of dealing with that or handling that is create a tuple object rather than a list object is a good practice or a best practice standard that they generally follow in a real world, guys. Okay, so now come back here. Everybody with me so far? Quick yes, please. Rahul, Shrishel, are you with me? Okay, now take a look at this, guys. Here comes students. So there is students, John and 95. So what is this, guys? Now what we have here is, so I come here, shows this one. Visualize a big tray in which there are 3 tuple trays, which are 3 small trays. That's a tray of trays. And inside each one, there is, let's say, there is coffee, 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 and then we have green tea, green tea, green tea. So this is a tray of trays where each tray has a coffee cup and a tea cup. Okay, so now come here, take a look at this. Where are we? John 92, any change here? Same thing. Okay, students dot sort. Now here comes the lambda functions. Aniket, were you referring to these lambda functions, buddy? Yesterday? Or are you referring to? Were you referring
No,
to
no, not this one. The AWS Lambda one.
That is like a little higher class, but we will slowly go there.
Yeah.
Get to there slowly. A little time on that. Okay, so now take a look at this, guys. Here is a Python Lambda. This is Python Lambda. This is not AWS Lambda. We'll talk about AWS Lambda in coming up days, guys. Don't worry about that. So what is happening, guys? Now, let me come back here. So I come here. Choose this. Okay, back to the big tray. Back to 3 small trays. The 3 pink trays. Now, the way it will work, guys, sort is a function. More precisely, it's a method, but for now, I'll call that as a function. And when we say lambda x is x of 0, visualize something like this is happening. Let's say, just for the sake of simplicity, I'll give it a different one. Say, choose this one. So the first thing what will happen is the x, lambda x means, I will give you a much more detailed idea about the lambda functions in the coming up ones. But for today, I'll probably, this is a slightly complex one, but bear with me, guys. Okay, the way it is going to work is the x is going to become this one. In other words, more precisely, let's say I come back here, choose this here. When you say lambda x, the first time it is going to become this pink tray. And what is happening? In this one, there is a coffee cup. There's a coffee cup here and another coffee cup here. And let's say green tea, another green tea. So now in this tray, x of 0 will end up being John. So that is going to be John. And what are we doing? We are asking it to sort. In other words, what this lambda function is generally only one line function. I'll show you how to write the lambda functions in the coming up days as promised. But now we are taking John, we give John and we are asking students to sort. Students is a list. You're telling, hey Trey, I want you to sort yourself based on John. Okay, so first it picked up John. So what is happening? Here is John. Let's say it picked up John, here is John. Then what it will do is, it will pick up the next item, which is now in the second, after it picked up John, it goes back to the second item, which is the blue tray. It picks up Aaron. And let's say, once it picks up Aaron, it puts it here. Now it compares these two. Which is lesser, well, A is lesser than John, so Aaron will be put here. And let's say this Aaron will be put here and get rid of this one. John will be there. Next, what will it do? Next, X will become this one. It will pick up David. So what is David? David is starting with a D. Cool. So now what will it will do? It'll compare it with John. It is less than that, so it will put somewhere over here. So that will be, put this here. So first Aaron, then David, then John. What is happening? The sorting is happening. Sorting is happening based on the lambda function. Why are we using lambda function? We have a nested structure here. This is a slightly, maybe a complex example at this stage, guys, but bear with me. I'm just throwing you a little light here, is what it is. So that's why we are observing Aaron first, David, and then John, ADJ. Visualize for a moment, that is how it is working, guys. Okay, now imagine for a moment, you don't want to sort it based on the name of the student, you want to sort it based on the marks of the student. Okay, so if you come back here, is this here? Now take a look at this. What you do, you can just change this to 1. 1 is 2 for Python. So now 92, 95, and 100. We have sorted them based on this one. Okay, so what is lambda function? You leave that to me. I will simplify it in a few days, but what is happening is that is what sort is. We are taking a slightly more complex structure here, sorting them in this order. Everybody catching in that, guys? Quick yes, please. Okay. So that is a little bit of sort there, lambda of x1. Okay, reverse equal to true. Just for the sake of discipline, we'll sort it based on the marks and we'll say reverse equal to true. So now we have Aaron, John, and David here after sorting it based on the marks, but we are reversing it. So notice David, John, and Aaron. So reverse equal to true is what we called as a argument. And we'll talk about that kinds of arguments also, guys. Okay, so we are hard coding the argument here is what it is to get it in reverse order. That's again a slightly deep one, so I won't worry much about that. Let's dig a little bit deep back to list object, a simple list, changing the list object to Nescafe. So for the sake of discipline, I think I just explained this one, but we'll run this again. There's a list, a tray of 3 teacups, then come here, list of 0, change it to Nescafe. Change it to Nescafe. Notice Nescafe 23, which means the list is allowing you to modify it. You can modify this tray, that's a list object, a square bracket. Come to tuple 1, 2, 3, a tray of 3 teacups. Try to modify this to Nescafe, and notice it will catch it. It will give you an error. Okay, so what do? Imagine, for the sake of simplicity, this is one way to do. Imagine you happen to have a tray, which happens to be a tuple. You're really interested in modifying it. What we can do is we can convert it to a list object. What do? You use a list. We're converting it to list object. You can think of list as a function or a class here. Class we have not yet talked about. We'll talk in the coming of days, but more precisely, we are typecasting or type converting. Okay, now what you can do, you can say a list of 0 equals to Nescafe. So if at all you created a tuple, if somebody created a tuple and there is a need or a requirement to modify it, then what you do is we can just convert it to a list object and then modify it. Everybody catching that, guys? Quick yes, please. This is called typecasting, type conversion, and things like that. Let's see, Rahul, and who else we have there? Shisha, okay, buddy? Nitesh, okay, good. Okay, back to the tray. Let's see what we have in the tray. 3 coffee cups, a list.extend. Now we are adding the coffee cups to this one. And let's take a look at a list. If you recall, extend is putting the individual cups. Nescafe 2-3, Nescafe Brew and Sunrise. Cool, guys? Okay, so what can you do, guys? You can say length, you're asking it, no problem. It will give you, Python will be able to say, hey, there are 3 in this tray, T. More precisely, let's say length of tray, that's going to be 6, I think. What's that? Oh, sorry, a list. This is a list. A list. You can give whatever you name, try to give meaningful names. Don't use your personal names and things like that in the professional world, guys. It may not be very meaningful to use personal names like that, okay? And back to the tuple. Now take a look at this, guys. Coffee and 2. This is a tray in which we have 1 coffee cup and 1 teacup, textual data and numerical data. Let's verify there is a T. And now try to modify the first one, coffee to Nescafe. It will give you an error. Why? That is what is tuple. It will not allow you to modify it. So what do? You check the type of it. Hey, what do you imagine for sake of simplicity? We're checking it saying, okay, it's a tuple. Now let's create tuple is 145. Okay, so 3 teacups, tuple 0. Now take a look at this, guys. Here is something slightly different. When we are creating a tuple here, we have given the open brackets. But notice here, we are saying this is tuple 0 equals to 145. Okay, and let's say come here, tuple 0, tuple 1. Okay, so if we'll say we just, you can give any name. Tuple 0 is 145. What is happening is, notice it is automatically creating a tuple. In other words, what I'm trying to convey is, generally what we do, let's say, you say cup equals to 1 is what you do. You can look at cup. This will be a teacup because that's a single object. So here is a single object. But let's say, you say instead of a cup, or let's say, I'll say this is a tray for the sake of simplicity. This is a tray. Call this a tray. I'll also call this. Copy this one. Paste it here. Now take a look at this, guys. 1, 2. But before that one, I'll put something like this. Here is a tray. The name of it is tray, but really, if you look at the type of a tray, notice it is an integer, which means it is really a numeric green tea. It is just a single object. But the same thing, say a tray 1, 2, notice what happens. It is creating a tuple. So what are we doing? What is different? When you create only here, you are assigning or initializing one object, whereas we are initializing 2 objects. So what is happening is, it is creating a tuple. By default, Python is creating a tuple when you initialize multiple objects. That is what is slightly different. Okay, let's say you say a tray equals to 1, 2, 3. It is internally taking the 3 teacups and putting into a tuple. It can put it into a list object, but maybe Python doesn't want you to modify it. That's why it's creating a tuple is something to be aware of. So here we are saying a tray. Tuple equals to 145. So I come here. Tuple equals to 145. When we initialize multiple objects at once, they're getting initialized into a tuple object is something to be kept in mind. Cool, guys? Let's say come here. Tray 2 is also 145. Now let's see what is different. Same thing. No difference here. Tray 2. It's a tuple object. Okay. Now take a look at this. This is probably, I probably don't need this one. 2 teacups and 1 coffee cup. And here we have given the open bracket and the closed bracket. It has created a tuple. More precisely, maybe, I think I should have shown you something like this. I will not give this tuple. And if you say print tuple 1, it will give you that one. And then we'll put explicitly an open bracket and a closed bracket. It will give you a tuple. In other words, when you're initializing multiple objects, if you can recall that it is creating a tuple object, that is what is required. You're just saving a few of the type, a little bit of typing, not creating those things, guys. Okay, so everybody with me, guys. You're understanding the initializing multiple objects at one time. Quick yes, please. Okay, good. Okay, so let's take tuple 1 and let's say a list. So let's say come here, list and tuple 1. Let's see. So there is a list. So what are we doing is we're just converting a tuple to a list object. We just show that. Can we convert list to? Absolutely. So good question. So let's say, I think earlier we created a list object. Let's see if we still have it. So there it is. Now what we'll do, we'll say TPL equals to tuple of a list and say TPL. And look at that. Notice it has been converted to a tuple. So you can do it 2 sides. Okay, Rahul? Very good. Okay. So now take a look at this, guys. Here is something interesting which is going on. Tuple 3 equals to, take a look at this. You do this one. Notice it looks like tuple 3 is an empty tuple. Let us see. We'll say type of tuple 3. Now it's giving you tuple. So it is. For a moment, I thought it will not create a tuple. It will create an empty object, empty cup, but it looks like it is creating tuple. But let's see. We'll stick with me. Now here is Nescafe, which is a coffee cup. Nescafe cup with coffee inside it. Tuple 4, take a look at this, guys. Is coffee. So if you say what is type of tuple 4, it will give you a string object. which is okay. The name, you can give any name. We're calling it tuple, whereas it is really a string object, a text object, and a coffee cup. Okay, but let's say, come here, say type of tuple 4. And now take a look at this, guys. A subtle difference is you say tuple 4 equals to coffee and you put the comma, and then you see how it looks like. Tuple 4. So notice it has created a tuple object. If you put a comma, if you don't put a comma, it is treating that as a coffee cup or as a coffee object. If you put a comma, Python is actually immediately creating an empty tray and putting the coffee cup into an empty tray, and that is becoming a tray of a single cup is what it is. In other words, it's more of a syntactical thing I want you to be familiar. Sometimes people may want to create a tray of a single cup. So what do? They'll just say coffee and they'll put a comma, and Python is creating a tuple of a single cup. Everybody catching it, guys? Quick yes, please. That comma thing is slightly, you'll be seeing it commonly when you're reading the text files, CSV files and things like that, is what it is, guys. Everybody with me? Quick yes, please. Okay, so that is a little bit something. Now here, again, one more time, we are creating a list object to a tuple. So come here. AB is a list object, we're converting it to a tuple. Normal brackets is tuple, immutable. Now again, tuple 6 is Nescafe. This will be a coffee cup. This will not be a tuple, no, notice, because we did not give a comma by the side of Nescafe. Cool? But you give a comma, that becomes a tuple. Just another repetition. Nescafe. Cool, guys? Okay, let's see what else we have. Tuple 6, Nescafe. No, take a look at this, guys. Here is something interesting. Here is Nescafe. This is a coffee cup, which is string object. And now what we're doing is we're explicitly wrapping it around a tuple. Now notice what it looks like. What happens? Notice it is actually creating a coffee, a string object. It is not giving you a tuple. When you say Nescafe, comma, it was giving you a tray of a single cup. Whereas when you explicitly say a tuple, what is happening is it is not creating a tuple or a tray, it is just creating. It is actually a little bit weird, maybe a little bit weird. Maybe I'm wrong, but it is something, a little bit of syntax that you want to keep in mind. The same thing, one more time we'll do it, but even though this is written in, now notice it becomes a tuple. The moment you create a cup object and put a comma, it is converting it into a tuple. Even if you say a tuple, explicitly, you're saying it's a tuple. You're saying, hey, give me a tray of Nescafe, which is a tray of a single coffee cup without a comma. Then what it is doing, it's just giving you a coffee cup and not a tray. Catching that, guys? Quick yes, please. Cool. Okay. Tuple 6. Okay, that's what it is, guys. Now let's dig a little bit deep into it. Back to the tray. A few gifts and a few coffee cups here. Take a look at this. There are two gifts, gift 1 and gift 5. Between them are 3 coffee cups. So now what you do, A star B. And if you look at A, notice that will be gift 1. If you look at B, notice that will be gift 5. And if you look at underscore, notice that is going to be the 3 middle cups. This is called tuple unpacking. Okay. So in other words, let me just come back here. Okay, visualize. We'll put 2 gifts here. So here's a gift 1, here's a gift 5. Then we have a Nescafe, brew, and a sunrise. These 3 are the coffee cups. So what is happening is when you say A star B equals to the tray, visualize what is happening is, if this is like a gift box, you're opening the unpacking gift box, making this as A, making this as B. And whatever is in between, that is becoming the underscore. Is what that's why A is gift 1, B is gift 5. This is called tuple unpacking or gift unpacking. This is a shortcut. This one line of code again. We may need to write 5 to 6 lines of code in other programming languages and code. Languages is what it is. This is more of a patternized code. just short and sweet and things like that. We can do some very, very powerful things using these, using techniques like that, guys. Okay, catching the point, guys? Everybody with me? The mantra I want you to keep in mind is what is called tuple unpacking. Just like you're unpacking a gift box and giving the gifts to others and things like that. It's called tuple unpacking. So now come here, the same thing, head, star, remaining, tail. So notice this one, the same thing. So here is head. Head is now going to be gift one. Tail is going to be the last one, gift five. And star remaining. So we can use remaining just in case you want to use the ones in between. That is going to be remaining. So when would we use an underscore is? Underscore is generally when you don't care. Here there are only three. But imagine there are a million things. And you just want the first and the last one, nothing else. That's when you use underscore. You can say star underscore. Okay, but let's say you also want to use the one in the middle for some reason in the next lines of code. You may need them. You can say, hey, put the remaining, the ones in the middle into the variable called remaining. Catching that, guys? Quick yes, please. Okay. Okay, that is called again tuple unpacking. Can we use this ampersand? Let's try that. I think the answer is no, but let me just give it a try here. So star again is a special keyword. Let's see if it's indicating. Okay, it's slightly in bold color and slightly purplish, not in green color, but this is a special character. So you cannot use an ampersand, is what that means. A star B, that is what we just looked at. You can use your own variable names, Niharika. Okay, but again, that's a personal name, Niharika. Notice about using personal names and things like that, guys. Okay, so back here, back to the tray, we've just seen this A star B, just seen this one. Cool. A star remaining, we have seen it. Remaining A star Ashutosh, we have seen it. We don't need this overkill. Cool. A star dollar. Let's see what happens here, guys. I don't know if dollar will be, looks like it's an error. I'm right away seeing the red color. I'm thinking that is probably going to be an error. Okay, Python is, compiler is not compiling it. It's not catching it because the special characters are compiled, taking a different meaning and a different context is what it is. So that is not a valid way. You can use underscore or give some valid name. Everybody catching the point, guys. Don't use any other special character. Underscore is being specially taken care of by or handled by Python. Quick yes, please. Okay, so now take a look at this with the same thing, the tray, and this time what we'll do, star C D E. So you can change that pattern in whatever way you want. Let's say you want the last two items, not the first two. So now D will become Starbucks, E will become gift 5, and C is going to be the first, except the last two, the remaining, star C. Okay, so just for the sake of display, let me quickly put this here, put this here, put this here. So Starbucks went into D, gift 5 went into E, and this whole thing, oops, one more time, choose that, except the last two, the whole thing went into C, is what is happening. That is unpacking. One more time, gift unpacking is the friendly mantra, technical mantra is tuple unpacking. Okay, now you can just say star underscore. Underscore is accepted by Python, we've just seen it. You can use it anyway, based on, you know, your requirement, whether you need the first two or the last two and things like that. So underscore will be the first one, and let's say D is going to be the Starbucks, E is going to be gift 5. Cool. Let's say print and print. Okay, so now take a look at this, guys. Here is print. A is A, B is B, C is C, D is D. Let's see what is happening here. We're using comma. Comma as a concatenation operator, if you recall. A colon. So when you use comma, notice when it is concatenating these two, it by default puts a space. It is separating by a space. The two objects, the two things it is concatenating, something to be familiar. Now, the same thing can also be written like this. Now, notice this one, F. This is called F string. F, A of A, B of B, C of C. And here, if you notice, let us say, if you notice, in F string, what is A? This syntax is referred as a placeholder that is referring to the variable A or an object A. Okay, so let's say, to make you understand that one, let me come back here. We'll say, here is Sachin. Sachin equals to, let's say, we take this one. Star CD. Copy this one. Star C. So that says star Sachin. Say D for Dhoni. And E for Shane. Shane Moore. Okay. So let's do this and let's see. To start with Sachin. So here is Sachin. The first few. Dhoni is going to be Starbucks. Shane is going to be gift file. Now let's see what else we have here, guys. Okay. So now why I'm explaining this one is, let's take this one. F string. I was trying to differentiate these things. So let's say A is Sachin. So notice Sachin. B will leave it like this. C will leave it like this. D for Dhoni. We'll put Dhoni here. And E for Shane. Sachin and Shane. Okay, so if we run this one, let's try. Notice the placeholder syntax. Gift 1 Nescafe. So what is Sachin here? What is slightly confusing is the syntax. This is called a placeholder syntax. This is actually referring. This F string is a special kind of a syntax in Python, where rather than when you have a lot of variables for the convenience and things like that, when you're referring to a lot of variables, A, B, B, C, C, D, D, and E, it might be confusing. If you give meaningful names, then within the F string, you're able to refer to the variable name using that syntax. When you use the syntax, you're telling F string, this is called F string. Hey, buddy, go and look and see if there is something called Sachin anywhere here. So Sachin is this whole thing. So that whole thing is getting printed here. B and C we didn't modify. Then D is Starbucks, which is Dhoni, E for Shane. So more precisely, when you look at code like this, these are referred as placeholders. They are nothing but you're telling, hey, look for an object called Sachin on the top. Somewhere in the global scope, I have created an object called Sachin. Are you all catching it, guys? Quick yes, please. Rahul, Kajal, Humera. It's a slightly deep one, but a slightly interesting and slightly useful one. You will commonly, and again, another modern way of writing the code and things like that, guys. Okay. Now take a look at this. Whoever this guy is, he's interested in the first two and the last one, but the remaining is not interested. Okay. So let's say you can also write in your own way, whatever patternized is your requirement. So now if you say A, you'll get gift 1, I think. B is Nescafe. And C will be gift file, the last one. And underscore will be whatever is remaining. Brew, Sunrise, and Starbucks. One more time, this is called tuple unpacking, guys. So here, this guy is only interested in the first one. In this tray, there can be any number of items. We are interested only in the first one, nothing else. So let's say A, you'll get gift one. Underscore is going to be the remaining ones. Cool, guys? Gentlemen, ladies, one more time. Quick yes, please. She said. Heavy there. Okay, let's do this, guys. Let's take a short 5-minute break. We're almost at 50 and we'll continue the journey. Everybody okay with that? I just need a little here. Thank you. Thank you, guys. Okay, yes, I'm back. Are you guys back? Can you give me a quick yes, please? Great. Thank you, guys. Sorry about that. So let's continue the journey, guys. Let's take another data structure here. So here is tray 1 and tray 2. Notice this, guys. Another new data structure. Tray 1, tray 2. A slightly important data structure. The list is what we have been already talking about. Tray 2 is a set. What is a set, guys? Notice this one. In a list object, we have 2 Nescafes, 1 Taj and 1 Group 1. But when you create a set, notice what happens. It is the 2 Nescafes which are duplicates of each other have been removed. Notice the syntax of it is looks like a dictionary. A flower bracket is what is a dictionary, which is cups and pens, keys and values. It looks like a dictionary, but it is really a tray. A tray of cups. The catch with it is you cannot have duplicates. You just need unique values, as simple as that. It is like a tray which cannot have duplicate values is what it is, guys. Okay. So again, tray 3, what we are doing is, which is list object, we are converting it into set object. Oops, pardon me. Undo that. Let's run that. Tray 2. So here is tray 3. And the 2 Nescafes have been taken out, and there's only 1 Nescafe. So in other words, a set is a tray which does not allow duplicates as a mantra. Tuple is an immutable tray. A list is a modifiable tray. A set is a tray which will not allow the duplicates. Cool. So tray 2 is set 1. Oops, come here. So come here, set 1. Again. Now take a look at this, guys. If you recall here, this name Avinash. What is this, guys? This is like a coffee cup, but behind the scenes, remember, coffee cup is a tray of coffee cups. A string object behind the scenes is acting like a tray of coffee cups. So what is happening is A is repeating two times. It is not a very, very important thing, but I'm just trying to get you familiar here that it is not allowing, even inside a string, it is removing the duplicate characters. Okay, so it is converting it into a tray object, and in that tray object, A is repeating 2 times. So it is converting it into a single occurrence, removing the duplicate and giving us that one. Catching the point, guys? Quick yes, please. Okay, and okay, now S1 of 0. Now here's another one, guys. About sets, something interesting or something which is not common is, if you try to access this tray and say, hey, give me the first one, it is giving us an error. It is not iterable. You cannot access a set like this and try to get the first element of that. But let us say, here's a slightly tough question. We are really interested in getting the first item inside this tray. What do you think we can do, guys? We want the first item, you ask it set, which is a tray, and it is not, you convert it to a list. Good one, Rahul. Maybe you have a little bit of programming background and things like that. Feel free to keep around, feel free to help your colleagues and things like that in case of other times and things like that, buddy. You seem to be answering all the questions very precisely. So what we'll do is, guys, we're converting a set to a list. And then you say a list of 0. List of 0, that will get you the first one. Good job, Rahul. Keep it up, buddy. Everybody with me, guys? Quick yes, please. Cool. Okay. Increase the complexity back to line 1, line 2, line 3, line 4, line 5. 5 lines of code, a for loop. What we are doing? We're creating 2 trays and adding the cups in the first tray into the second tray. What can you do? Well, the modern way of writing the code is do it in 1 line. There's actually 2 lines we can say, including the declaration. That is 1 line of code. This is called list comprehension. List comprehension is generally 1 line of code. Is the first mantra. The second mantra, it is generally going from right-hand side to left-hand side. Okay, guys, we just looked at that. Let's see what else we have. One more time, 1, 2, 3. Now take a look at this, guys. 1 line, 2 lines, 3 lines, 4, 5, 6, 7, 8 lines of code. 8 lines of code. Okay, we are picking up each cup in the tray. If the cup is greater than or equal to 5, then we are adding 1, otherwise we are adding a 2. Is the logic. More precisely, 8 lines of code. What will we do? Notice this one. 1 line of code. We're exactly producing the same output or getting the same output. Cool. So let's say quickly go back here. Okay, so here you start with the tray, then you create an empty tray, and then you're in the next step, you're checking the condition. So you're picking up the cup. So let's say cup 1, cup 2, cup 3. Pardon me, sorry about that. One more, I guess. Okay. So you pick up the first cup, that becomes a cup. You're checking if it is greater than or equal to 5. So 1 is not greater than or equal to 5. Result dot append. Result dot, if it is greater than 1 is not greater than or equal to 5. So what you do is you're going to this one, cup plus 2. This one you're adding it, and that is becoming a 3. We're doing a cut and a paste, but you visualize as if it is copy and paste. Then you pick up 2. This is also not greater than or equal to 5. So that is becoming a 4. Repeat the same thing. That becomes that, and it comes here because that condition doesn't get satisfied. The if condition doesn't get satisfied, that becomes a 5. And that's what we are saying here. Now that is 8 lines of code. Here is 1 line of code. What is happening, guys? Let's see. Take a look at this. Now here, it will first start here. This is going to be the first line. It is on the right hand side. We'll be executing from right hand side to left hand side. From here, we will come back here. We'll put this cup back here. Put this one here. And put this one here. Now what you do? This will become X for cup. From here, what is going to happen is it is going to jump to the if here. And then it's checking this condition. Is it greater than or equal to 5? No. So now, choose this one. It jumped here. The condition is false, so it is going to go into the else loop. That will become 1 plus 2. 1 plus 2. From here, what is going to happen, guys? You visualize. You visualize for a moment. On the left-hand side is another tray. There is a tray. So 1 plus 2 is becoming 3. That is being added here. Let's give it pink. Okay, then again, take this cup. This becomes X. Go into the if. Is a condition true? No, it is not greater than or equal to 5. So the else is getting executed. 2 plus 2 will become 4. So that will come here. And that is going to become 4. Repeat the same thing. Come here, pick up this. Go to the if. The condition is not getting satisfied. That will become 3 plus 2 equal to 5. And that is going to become that one. Everybody catching it, guys? Quick yes, please. So here it is kind of, we are nesting a for loop, we are nesting an if and an else. 3 of the things are coming in one line. Catching it, guys? Just one more time. Give me a quick yes, please. And more interestingly, from here, it is going to the left-hand side. So we are going from right-hand side to left-hand side, jumping it and putting it in the, visualize always our final trace on the left-hand side. That is this tray. Cool, guys. So what happened here, guys? 8 lines of code, roughly 7 lines or maybe 8 lines of code has been reduced to 1 line of code. That is called list comprehension. Cool, guys. So what is happening? Ideally in a for loop, you pick up each cup and then you do something. So that is what is happening. In a list comprehension, the for loop is on the right hand side and do something is on the left hand side. You do something in what you do that is getting added to the tray in the left hand side. That's how you visualize. Okay, guys, this do something is our requirement or whatever processing that we're doing and things like that. So for each thing is nothing but a cup in a group of things, you do something. Okay, so again, one more time, the same thing, just using a different wordings there. First, the right hand side is getting executed, then the left hand side. Cool, one more time. 1 line, 2 line, 3 line, 4, 5, 6 lines of code. New numbers. Oops, one more time, go here. Let's start. We get new numbers is 0 to 9 has become 1 to 10, short and sweet. In our tray, we had 0 to 9, they have become 1 to 10. We're picking up each number, we're just incrementing it to by 1 and adding it to a new tray called new numbers. Cool. So let's say come back here. So now take a look at this, guys. 1 line of code. So one line of code. So there's the number. You pick up each number, you add it, number plus one, whatever is the processing you're doing, and then from here, you visualize as if it is adding to this part of the tray on the left-hand side. If you can visualize that one, that will be very, very helpful for you in understanding in a simple way. Quick yes, please. Rahul, Sumit. Thank you, guys. Okay, now just for sake of discipline, we're doing another operation here. Print the numbers. Numbers are from 0 to 9. And we're doing a /3. So now we go from 0, 0 by 3, 0, 1 by 3, 0.33, 2 by 3, 0.66, and so on. Okay, the next one, round of number by 3, as the name suggests round, round is rounding it. So it is truncating the decimals. Remove the decimals, what you have is 0. 1 by 3, 0.33, so that is why it's becoming 0.33, right? Rounding it. This is rounding it to 1. 0.33 has become 0. 0.6 has become a 1. That's because it is greater than 0.5. That's what is back to school and things like that, if you recall this. So again, remember the mantra is, it is list comprehension. It goes from right to left and it is one line of code. Cool, guys? Gentlemen, ladies, increasing the complexity, going to slightly more deeper concepts into Python. Say hello. Say hello, no problem. But take a look at this. This will give you a problem. Okay, for us, this is a problem at a slightly friendly level, but for Python, it is an error. What is an error? Error is an exception. Behind the scenes, we call this as an exception. What is an exception? Exception is something Python doesn't understand. Okay, you're asking it to do something it doesn't understand, it's saying it's an error. Error is behind the scenes is what is called an exception, guys. Okay, if you give two single quotes, Python is able to understand. It is able to compile. But if you give only a single quote, it is not able to understand. Is what it is. What is that? That is an exception. The mantra of an exception is something Python does not understand to do. Is something I'll ask you to manually remember, guys. Okay. So now, why is that important? Sometimes when we write the code, we know it is going to work, but sometimes we are not sure. When we are not sure if it is going to work or if it is going to give an error, then what we can do is that's where the exceptions come in, and we know how we should know what to do. Okay, so what will we do? Now take a look at this. 2 plus S is a teacup and a coffee cup. Python understands a 2 plus 2, but does not understand a 2 plus S. 2 plus 2 is 4. 2 plus S is adding a teacup to a coffee cup. You can add a teacup to a teacup, but you cannot add a teacup to a coffee cup. That will mess up the drink. In other words, Python does not understand. That is an exception. Okay, so what do? That's where you bring in try. Imagine, for sake of simplicity, we are not sure if it's going to work. What do? You say try. It will give an error. Why? With try, we should always say except. We are writing some code. There is a chance that we are getting an error. Okay, so if you look at this kind of error, this is a very, very awkward error. In other words, this is something which is not really a friendly error. What do? Well, if you give this kind of errors to users or using your script or thing like that, they might feel very uncomfortable. And in a professional world, we don't, it's not a professional way of handling the things, guys. Okay, so what do? You say, hey, you're giving a friendly error. If something happened here, maybe something is a problem. There was some problem here. It is kind of a more of a friendly explanation. In other words, it is better to look at this kind of a friendly error message than this kind of a complex compilation error things and so on. Users will not be able to understand. So what do? You give much more friendly errors. What is that? That's where an except comes in. In other words, let's say, come back here. So here we go. Put this here. Put this here. So what happens here is it first tries to execute this one. From here, if there is any error, it is jumping into the except block. 2 plus S. That is what is happening, and that's what we are saying. But let's say, come back here. Say 2 plus 2. 2 plus 2 is a pretty straightforward operation. Let's say run it. No problem. In other words, now nothing is getting printed. So if you look at this, from here, it did not go into this block because everything was correct here. In the previous step, it was not correct. If it is not correct, there is an error. If there is an error, what will it do? It will go into the except. Except is like an error. Except is an exception. For the sake of simplicity, we'll call that as an error. From a slightly deeper computer science standpoint, again, there is a subtle difference between error and an exception. But for us, we don't need to go that deep. At a slightly high level, there is no error. If there is an error only, it will go into the error block. The error block is the except block. Everybody with me, quick yes, please. Good. Rahul, keep helping others, buddy. You're catching everything. That's a good one. Okay. So it's like, you know, somebody is cooking a curry. Imagine Rahul is cooking a curry, and let's say 2 plus 2, more precisely, not 2 plus 2. So 2 plus 2 is a good curry. No problem. Will there be any problem? Well, there will be no problem. Okay. Or in other words, let's say instead of 2 plus 2, let's say print cooking. Print cooking. Eat curry. Print cooking a curry. No problem here. Print is good. Say come here. Cooking curry. So cooking a curry, no problem. But the same thing, we'll say cooking a curry, trying to cook a curry. For the sake of discipline, we'll try this one. Oh, something missing. In other words, what happened here? Print trying to. Oh, this is a syntax error. But why is it doing this one? Oh, syntax error, guys. We didn't catch it. Strange. Yeah? Exception should be a global exception. It's a syntax error. Okay. That's slightly deep one. This is slightly deep one. Rather than this one, I will say, I will not confuse you. 2 plus S. Well, I'll come back to global exception in a bit. 2 plus 2. So if you're cooking a curry like this, okay, what will happen? That's an error. You are adding tea and coffee together. Problem. That's a problem, right, guys? So here, if you do 2 plus 2, if at all you're adding, we'll give that error. But let's say, okay, start with here, just for sake of discipline. 2 plus S is a bad thing. You're adding tea and coffee together, not a good thing. You'll get an error, and that's what is the problem. Don't add tea and tea and coffee. Do not. Oh, as simple as that. But let's say, what's the meaning more meaningful? No, take a look at this, guys. Here is back to 2 plus tea and coffee. We'll put that back. Let's clean up. So what are we doing? From here, this one, this one. So we're trying to add tea and coffee, we'll get an error. And then we'll do finally. Let's clean up. Which means, notice this. We're adding a tea and coffee, which is not a good idea, so we're getting an error. So Python is catching and coming back and saying, hey, I did not understand. You can add a tea to a tea, or tea to a tea to a tea, or coffee to a coffee. But adding tea to a coffee is not a good idea. And what's happening? In other words, let me go back here. Come here, choose this one. So try to add this one, goes into the error. It gives you a clean error message. From here, the final is getting printed. And in other words, somebody decided, okay, we'll not make the tea or the coffee will go out. So let's clean up. You're cleaning up. In other words, finally is getting called after the exception, after the error, the final is getting called. Is one way to think of it, guys. Okay. Another way is the same thing. Put this here. We'll do a T to a T. Now notice what happens, guys. So I put this here. Now notice we're only doing a cleanup. There's only a cleanup which is appearing here. Put this here. Put this here. So this is a good operation, no problem. Adding a T to a T is a good one. So there is no error, but and then after that the finally is getting called. In other words, the cleanup is always getting called. Whether there is an error or whether there is no error, the cleanup is going to be getting called. In other words, short and sweet, the finally is always called whether there is an error or no error. Many times imagine you're opening a file, or maybe you're connecting to a database, or maybe you're checking a server. You're pinging a server and you're not getting a response message back. What do you do? At the end, you should do something, whether there's an exception or no. Sometimes we'll know what kind of errors we might get. Sometimes, many times we will not know what kind of errors we get. What do you do? Well, irrespective of both, you want to do something at the end. What is that? That is finally. Oops, pardon, sorry. Okay. So short and sweet, the mantra of finally is it will always get called. The mantra of except is error. Error is something Python does not understand. Try is something, the curry we are making, the tea or the coffee we are making, or the code we are writing. Everybody with me, quickest please. It's a slightly deep one, slightly tough one, slightly advanced one. Rahul and Sumit. Good, Nitish. Cool. Let's see what else we have, guys. 2 pluses, something is missing in the curry. Krishna is cooking something. And what is this? This is definitely not right. Okay, so what is it? We will get an error and we'll clean it. The same thing, just another example. And come back here. Okay. So now take a look at this, guys. Increasing the complexity, bear with me. I'm going to stress you a little bit. Here is except. Let Krishna do the cooking. Say, come here. Let's run it. Something is missing. So obviously tea and coffee are being put and we are saying, hey, something is wrong. Okay, so now what is this one, guys? It went into, this is called exception. But take a look at this. We will use what is called a type error. Type error is more of a specific exception. So let's say, we'll come back here. If you do a 2 plus S, okay, something, we'll say, wrong, buddy. It's saying, hey, something is wrong, buddy. Hey, something wrong, buddy, is what he's saying. Let's clean up, let's go out and have a tea or coffee, if you say. So what did Krishna do? Krishna was trying to mix tea and coffee and he gave it to somebody. And he's saying, buddy, something, we know this, saying, hey, buddy, something is wrong. Okay, but next again on another day, imagine Krishna repeated the same thing, but let's say here is Sumit. And what is Sumit saying? Sumit is going to be a bit more specific. Let's say, looks like looks like it is tasting like tea and coffee. So what is the difference between this error message and this error message? When we know this saying, hey, something is wrong in the tea or coffee, it's like a very general error message. He's not being very specific. Whereas we come back here, in this error message, let us say this is Sumit, he's saying, buddy, this looks like, tea and coffee. And then, yes, Krishna is saying, hey, buddy, yeah, that's what I did. I mixed up tea and coffee. So what is the catch here? The catch is type error. This is called a specific error. Sometimes we have specific errors, we will be able to catch the specific error. So we're being more specific is what it is, guys, okay? So let's say if you run this one, what is this? Looks like it is tasting like tea and coffee. Instead of saying, hey, it's not good, I don't know what is wrong. That's like a very general, very general message. We're giving a more specific error. This is called a specific error or a specific exception. There are 5 or 6 of these specific exceptions that generally we need to be familiar with, guys. That's what that is. And remember, finally, something always getting called. Irrespective of your error, whether there is an error or not, finally will get called. And at the end, they're always cleaning up. Whatever they do, they're cleaning up and going. It's always good practice to clean up your resources and things like that, guys. Okay. So now take a look at this, guys. Except, and let's go to restaurant. So they're doing the same thing. Let's put, so let's say, put this here. He's mixing, Krishna is mixing tea and coffee. There's a, and who's that? Sumit is catching it. Hey, buddy, I drank it and it looks like it's tea and coffee. I don't know what you did. And then it's okay. They decide, hey, let's clean it up. Let's go to a restaurant. So now there is a subtle difference between cleaning up and let's go to a restaurant line. Tell me what is the difference, guys? What is the difference between these two? Can anybody give a thought? It's maybe a silly question, but for the sake of discipline, what is the difference between these two? Ah, good one. It is the scope. The cleaning up stage is in the scope of finally. Let's go to a restaurant is in the scope of a global. You're outside the scope. If you have that indentation, you're inside the scope. You're inside some room. Global scope is in the part. Something again more of a syntactical thing from a computer science standpoint. Always, I mean, keep thinking in terms of scope, guys. That's what that is. So let's say 2 plus 2 is no problem. You add a T to a T, that's a good curry, that's a good thing. And if you are getting ready for a type error, so who's this one? Let us say this is a guy, you're cooking a curry here. And now we'll say you're cooking a curry. Let's say hash cook a curry. You're cooking a curry. 2 plus 2 is a valid curry, no problem. So you will not going to accept. Okay, and then you say finally, you will go and clean it up. After you cook a curry, you're cleaning up, no problem. Okay, but let's say this is play cricket. Okay, so one more time, notice you cook the curry. If there is an error, if salt is less, you can catch it. But let's say you clean up and then you're going and playing cricket. Playing cricket is in global context or global scope. You clean up and play cricket. Cook the curry, play and play cricket is what it is. But let's say now adding a teacup to a coffee cup. Now take a look at this, guys. Here is something deep again. You are adding tea to coffee and you're saying type error. What is type error? Type error is a specific error. It's like when you're cooking a curry, let's say Shri Shail comes to your house. Sumit is cooking the curry, Shri comes to his house. And what does he do? He tastes, he gives him a sample, a spoon of curry and says, hey buddy, how's it? So Shri Shail is an expert in only identifying the salt component of the curry. If salt is not good or salt is not enough, he'll say, hey buddy, add a little bit more, or this is too much salt, is what he might say. Okay, but if the spice is more, if any other component of it is more or less, he's not able to identify. What is it? That's the problem here. Except type error means except specific error. So let's see what happens here. Take a look at this. So let's imagine Sumit cooked the curry and Shri came to his house and he says, hey buddy, salt is not enough. So you're going to add a little bit more salt, no problem. You're cleaning up, you're playing cricket. But let's see if I have that here. I think I need to put this here. Let me put this here. Put this here. Now accept type error. Now let's say accept type error. Okay. Accept. When you say accept, you're not being specific. You're saying something missing. If you just say accept like this, something is missing. You just say when you say something is missing, Sumit may not understand. Whereas when you say salt is missing, that is being very specific. He knows exactly what to do, what is the problem and things like that. That is the difference between specific error and this is called a global exception. Okay, now what else can you do is, let's say come here. Let's put this here. It is except. We'll do both of them, which is except we'll put here. Put this here. Now, this is specific error. This is global error. Put both of them. 2 plus 2. So that is a salt error. Error in the salt. This is a specific error. The specific error is on the top. The global error is in the below. What is happening is Shri is catching it and saying, "Hey, buddy, salt is not enough." And then they're playing cricket. In other words, what I'm trying to convey, you can have a specific error and a global error at a time together. Is what that means. Okay, the same thing, do the reverse, which is, notice, cut this here, put this here. Oops, no time. Now notice, run this one. Notice it will give you an error. What it is saying is except must be last. Before you say something is missing, you have all your conditions. You check for your salt, you check for your spices, the brinjal or whatever that you're cooking and things like that. In other words, except is referred as a global exception block, should always be at the last, not in the front. Catching the point, guys, okay? There are two things here. You can have multiple errors you can catch. The second thing is the global exception should always be at the end, not in the, on the top is something you need to manually keep in mind. Quick yes, please. Cool. This is slightly deep and slightly tough one, guys. Bear with me. Little too much of hammering going on today here. And as simple as that, except. Cool. Okay. It's like I have another one coming up here. Okay, just give me a moment. Okay, sorry about that, guys. Let's see where we are. Okay, guys, another concept for today, slightly advanced. We're going into a little bit of object-oriented programming and things like that. Another thing is what is called a class person. Okay, so before we understand what is a class, let's try to understand the friendly mantra of it. Imagine, say, come here, choose this one. Imagine a person. Now, every person in the real world, let us say, has something. Say, oops, do this, put this here, has something. And what will we do? We'll say every person has a name, age. For the sake of simplicity, we'll say salary. And every person does something. Cool. Say, does something. Come back here. What do they do? Let us say for the sake of simplicity, we'll choose this one. We all eat, we all play, we all exercise. Cool. So now come back here. Has and does. Under has, we have name, age, and salary. And choose this one. Under does, we have an eat, we have play, and we have an exercise. This is in real world. Now, what you do in an object-oriented world is you take a design like that and converted it into an object-oriented design, which is, choose this one. You take the person, oops. You take the person, you design a class. This is going to be a class. Then you take the name, age, and salary. These will become the attributes. The eat, play, and exercise will become the functions or what is called the methods. What is this one? This is called object-oriented design. Okay, now that's slightly at a friendly level. So what did we do? What we are doing is, we'll say for the sake of simplicity, we are thinking, come here, in terms of a has and in terms of a does, is what we are doing. And then whatever is has is becoming the attributes. Whatever is does is becoming the functions of the methods. So let's dig a little bit deep into it, guys. Okay, so here is a class person. What you do, you say class person. I'll give you an error. What you do, you put a class person. Notice the colon comes to your rescue. Again gives you an error. What you do, you need to put a colon. You also need to put a tab, and you need to say pass. What is that? That is how you define an empty class. This is a class. A class is like an architectural plan. Imagine you want to build a house. What is the first thing we do? We go to the architect and we try to get an architecture plan. What is the architectural plan? An architectural plan is a class. The class, more precisely, is like an architectural plan. With one class, we can build any number of houses. What is a house? A house is an object. So in other words, so take a look at this. You can say Sachin equals to person. You can say Dhoni equals to person. So class is an architectural plan. The mantra of a class is an architectural plan, and the mantra of an object, Sachin and Dhoni, are called the objects here. They are called houses. Everybody with me so far? Quick yes, please. The first mantra of a class is architectural plan. The second mantra of how you design a class is where the has and the does is coming into the picture, based on the has and the does. Okay, so in other words, let's say, come back here. Choose this one. Imagine here's a cricket player. What does a cricket player have? Let's say, come here. The cricket player has, let's say, a bat, ball, and let's say wickets. Cool. And what does a cricket player do? Let us say, choose this one. Does. And we'll put this here. He will do batting. He will do ball. For sake of simplicity, we'll put it like that. So what are we doing? We're thinking in terms of has and does. There's a has, there's a does. Under does, these things are coming. Under has, these things are coming. Is one way to think of it, guys. Okay. So now let's go one step deep into this one. Take a look at this. Increasing the complexity a little bit. Something, so a little bit of basics of object-oriented programming. You need to have an idea of this. It's a slightly important one. So take a look at this class person. Inside a person, we are adding a function called init. It's actually double underscore init. So let's say we'll define this one. Come here. Now, what we'll do is we create an object. Sachin equals to person. Now, notice what happens. It is printing this one. I'm in constructor. In other words, what is happening is this is a place we are creating an object. Come back here. Put this here. When we create an object, what Python is doing is Python is internally calling this function. The function inside a class is not called a function, it is called a method. And what is special about this is a special method, it is called constructor. In other words, there are 3 lines of codes here. There are 5 or 6 concepts we are talking about. What is that? That is object-oriented programming. Generally, why people don't like programming is in just 1 or 2 lines, there are 5 to 10 concepts plugged into that one. Until we understand all these 5 to 10 lines of code, we will not be comfortable writing the code. That's why generally people don't like programming. That's what makes the programming a little bit hard. Okay, so again, there's only 3 lines of code, but there are roughly 5 lines of concept here. So if I were to undo this one, class is an architectural plan, object is a house. Okay, and person is designed based on as and does. When you create an object or a house, Python is internally calling a special method called double underscore init. The double underscore init is called a constructor. Every class generally, we have a constructor we will try to understand that. And then there is another thing called self. What is self? Self is called a self-referencing variable. You don't have to know everything today, guys. In the coming up days, I will go over these things a few more times, and you will naturally understand them. So just bear with me. Self is called self-referencing variable. And why is that useful? Self is something which is used to self is something which we do not pass any arguments. But I'll come back to self and things like that. So notice 3 lines of code roughly, maybe 7 or 8 concepts are coming into the picture. That is why object-oriented programming is a little bit tough and hard, guys. Okay, but let's dig a little bit deep into it. Let's come back here. Sachin, Dhoni. And so in other words, a slightly important thing for now, I'll say is, of all of them, when we are creating an object, here we're creating an object is the first important thing. Python is calling a special method called double underscore in it. That is called a constructor. Python, whenever we create any class, it will call this constructor. Why is it called constructor? At the time of constructing an object, it is getting called, so it is called as a constructor. In the Java and the .NET world, the constructor is generally the same name as that of the class. But again, we don't need to go there. That is just an FYI. Okay, so let's see what else we have. Okay, come back here, last person. Let's go. Hold on one moment, guys. Sorry about that. Okay, sorry about that, guys. Okay, so now we were just saying we're thinking in terms of the has and does. What do we do, guys? A person has name, age, and salary. So what do? They become the attributes. How do you do? This is how you put them or convert them into attributes. Come here. Say, come here. There it is. Now notice what happens, guys. Sachin equals to person. Notice it will give you an error. Okay, so what is happening is, discard this, put this here, take this one. When we create this one, create an object, Python is calling this method. And notice 1, 2, 3, 4. There are 4 arguments here. Notice we didn't even pass one argument here. What is that? That's a problem. If you scroll down a little bit, it says missing 3. There are 4 of them, but it says missing 3 because for self, you don't need to pass it. Self is called a self-referencing variable. I will explain a little bit more about self, but for now, we need to manually remember that for self, we don't need to pass any arguments. Everybody with me? Quick yes, please. Rahul, Shri, are you with me? Sorry about that, guys. Slightly going deep into the programming, but that's a little bit nature of the programming, guys. Okay, and these things we'll review them in the coming up days, and we'll make them more natural for you, so that you can deal with much more complex things. Okay, so now what we should do is come back here. For name, let us say we'll call him as Tendulkar. We'll call him, let's say, I think he's close to 50 years old. And let's say his salary is 100. Now notice this one. There it is. We have successfully created an object. And what can we do? Take a look at this. You say Sachin dot and do a tab. Notice there is age, name, and salary. If you say name, you get Tendulkar. You say Sachin dot do a tab. Say age. You get the age. Say Sachin dot salary. You get the salary. What are we doing? We're able to access the attributes. Why did we put the name, age, and salary? Thinking in terms of has and does. What is this? This is called object-oriented design. You think in terms of your has and does, and you try to create that, guys. Okay, what do? This is called a constructor. What do? You generally, whatever attributes you think, you pass them as arguments to your object. And what is this? This is called the state. This is called the data of an object. The data of an object is called the state of an object. You can change the name, you can change the age, you can change the salary. The data of an object can change, the state of an object can change, is what it is. What is that? That is what is called state. Okay, so what did we do, guys? We created Sachin. We passed in the arguments, name, age, and salary. What is name, age, and salary? We call them as the attributes, or we call them as the variables inside the class. The variables inside the class are called instance variables. An object is also called as an instance in an object-oriented world. You can call it as an object, you can also call it as an instance. These are variables. More precisely, in an OO world, that people call this as instance variables. Slightly deep there, 5 lines of code, 10 lines of concepts coming in there. Everybody with me, quick yes, please. I know it is slightly deep, but bear with me. We'll simplify it more in the coming up days, guys. Nitish, Rahul, okay, buddy? Cool. Okay. Okay, so that is the story of the attributes, and let's see what else we have. Sachin, there is Dhoni creating another object. So this is a line of code which I will say manually remember, guys. So here is Dhoni, Mahendra Dhoni. You can give whatever name you like. We'll call this as Mahendra Dhoni. Just to Mahendra Dhoni. So run it. So Dhoni is the name of the object. Mahendra is his name. And another subtle thing that you want to keep in mind is, notice the attributes are name, age, and salary. A name, an age, a salary are nothing but the arguments. The arguments are different from name, age, and salary. I can also just give the same name as name, age, and salary. Okay, generally you give, just to be kind of slightly clear, you give different names for the arguments and you use the original names for your arguments is what it is. Catching it, guys? Quick yes, please. So short and sweet, more importantly, these are arguments, these are attributes. You give whatever name you like for the arguments, you give whatever is meaningful name for the attributes. You can just say A1, A2, A3 here, but these you always keep them as meaningful so that others are able to understand easily. Catching it, guys? Okay. Now take a look at this. Here is a cricket player. What does a cricket player have? A cricket player has a bat, has a name, a bat, and a ball. There is Sachin. Say, come here. There is Sachin. Okay, let's come back here. Back here. Scroll up. Just to keep it clear, we'll call this as Tendulkar. Tendulkar. Change this to Tendulkar. Cool. So cricket player has a bat and a ball. What do we do? Cricket player Sachin. So now if you say Sachin dot do a tab, notice bat, a ball and a name. Start with name, you're accessing the name. Sachin dot do a tab, access the bat, it's an Amarat bat. And what is important, guys? A cricket player has a bat and a ball. What does a badminton player have? A badminton player has a racket and a shuttle. That's cool. So name badminton, name racket and a shuttle. There we have Sindhu. There it is. And now you say Sindhu dot do a tab, say name. Okay. Its name. You're able to access the name. You can say Sindhu dot one more time. Sindhu dot do a tab, say racket. You get your next racket. How did we get name, racket, and shuttle? What we are doing is we are designing it. How are we designing it? We're designing it in terms of has and does. Everybody catching it, guys? Quick yes, please. Cool. So you can think. Let's see. Okay. So now back to a little another aspect of it, which is a person has a name, age, and salary. What will a person do? A person will eat, play, and exercise. So let's start with eat. Notice eat. Eat is a function inside a class. The scope of the function is inside the class. The scope of the function is not outside the class. Okay. So what do you do? So let's say we'll add a function called eat. Function called eat. And now take a look at this, guys. We'll try to call this function called eat. Notice we'll get an error. We cannot call the function eat. Why? In order to call the function, you need to create an object. How do you do? Let us say Sachin equals to person. What do we have name, age, and salary. So let's say Tendulkar, comma, age is, let's say 50, comma, salary is 100. Say Sachin dot, do a tab, and we'll now call the eat method. So what is it? In order to call the eat, we are using the object. What is it? That is what is a method. You cannot call eat directly. When you call eat, he's eating idli. But how do? You first create an object. What is that? That is the difference between function and a method. Earlier, we have created various kinds of functions. Now we are creating a method. What is a method? A method is a function inside a class. How do you call a method? You need to create an object. What is this? This is called security. You're securing your methods is what it is. You need to go through the object. You cannot call them directly. Is one way to think of it. With me, guys, quick yes, please. Cool. Rahul, Shri, Nitish. Okay, good one. So that is such an eat. And let's say, come back here. Now, take a look at this. We also know a person will eat, play, and exercise. So what do? You add more functions or more methods into it. Cool. There is a person. Now, say, copy this one. This Tendulkar. So here is create an object again. And now Sachin dot, there is eat, here is play, and here is exercise. So let's say play. If you say play, notice badminton or cricket. And notice this, guys. When you say play, in the method play, you have self. This self is actually telling, in order to call this function, you need to create an object of this class. But self will not take an argument. So there are 2 or 3 concepts in just the word self. It is called a self-referencing variable. It is telling, hey, if you want to call this method, create an object. And there is no, we don't pass any arguments. 1 word, 3 concepts there in that object-oriented concept is what it is, guys. Okay. So Sachin.play, he plays badminton or cricket is what it is. You can call exercise, you can call it how you're thinking in terms of does. Has and does is how you are going about doing the object-oriented design. Catching it, guys. Quick yes, please. Cool. Okay. Now, apply this to cricket player. What will a cricket player do, guys? A cricket player has a name, bat, and a ball. He will do batting, he will do bowling. So there it is. Come here. Cricket player, he's doing batting and bowling. So let's say come back here. Here is Sachin again. Put this here. Oh, this should be. Hey, what do I do? Sachin. I have Sachin used all over the place. Let's try to. Okay. Tendulkar. I think we're here. So do batting and bowling. Sachin. So what I really have to do is copy this class and put this here. Not the person class, but the cricket player. So Sachin Tendulkar will create an object. And then we'll say, oops, Sachin dot, say do batting. Okay, he's saying I'm ready to bat. You can say Sachin dot do bowling. So what are we doing? We're calling the methods of the functions to bowling. There it is, I'm ready to bowl. Do batting and do bowling is what a cricket player does, bat and ball. Okay, apply that to badminton player. What will a badminton player do? A badminton player has a name, age, racket, and a shuttle. A badminton player will do service and do smashing. Okay, so let's say I come here. Do service. So now we'll say we create an object called Sindhu. And let's say Sindhu dot do a tab. Notice do service. You start with service. Notice this, guys. What's happening? Notice what I've missed. Self is missing. In the declaration, the self is missing. I need to put the self there. Then create Sindhu and now say do service. So the self is like a must. So what is do service and do smashing? They are methods. More precisely, we are designing them as methods, not as functions. A function is something which you can directly call, but a method is a function where you need to create an object to call that method. Catching the point, guys. Quick yes, please. Nitish, Rahul. Cool. Nitish, okay, buddy? Okay. That's badminton. That is the story of the badminton player. The service, you can put whatever you want. Now take a look at this, guys. A subtle change here. Here is a badminton player, and you're adding a bat and a ball. What is this one? This is wrong object-oriented design. You should not design like this. A badminton player does not have a bat and a ball. Don't design. You design like that. Okay. So it will work. If you write this one, and if you say here is, let's say come here. Here is Sindhu. Don't do a tab. Notice it will have a bat and a ball, but that is wrong object-oriented design. Catching the point, guys. Quick yes, please. Okay. So now apply the same thing for a car. What does a car have? A car has a name, age, brakes, and tires. They are the attributes. Whatever is an attribute, generally you initialize them inside a constructor. Double underscore in it is a constructor. It is called a constructor because it is getting called at the time of constructing an object. What do you do with a car? You could start a car, you stop a car, you accelerate a car. Cool. So there is start, stop, and accelerate. And here is Honda. This is an object. And if you look at Honda, dot do a tab. Notice you have a start and a stop and accelerator methods. Then age, name, brakes and tires are the attributes. Honda dot, let's say start. Started the car. Catching the point, guys. What are we doing? This is object-oriented design. For a car, you will have a start and a stop. You accelerate it based on what you think you do in a real world. You try to convert them into functions or methods in an object-oriented world. And for a cricket player, you do batting and bowling. For a badminton player, you do the service, you do the shuttle. Everybody catching it, guys. Quick yes, please. Cool. Okay. Okay, gentlemen, ladies, I think for today, we've discussed a bunch of topics. I think that should be enough for today. If time permits, please try to practice a little bit and review them, guys. Slowly, we'll get into a little bit of AWS and all those things. These are some of the basic concepts we need to have before we get in there. And hopefully I'll be able to help you understand the more concepts related to that aspects of that, guys. Okay. Any questions before we wrap up today, guys? Everybody doing okay? Everybody able to follow me, guys? Can you give me a quick yes, please? Anybody having difficulty? Okay. Looks like Rahul and Nitesh, they're answering a lot of questions. Please feel free to get with them, have a quick review, and feel free to get with them and try to do a little bit of practice, guys. Okay, it will be helpful for you, and you will be able to help more to your team and things like that. Cool, gentlemen, ladies. For today, I'll stop it here, and we'll continue the journey from tomorrow. Can you give me a final goodbye, guys? Thank you, guys. Appreciate it. You guys take care, stay safe, keep learning. Okay, signing off for today. Thank you and bye for now. Thank you again. Bye now.